Cool. So hi, we're Alex and Alex from Lume. So Lume is it's a virtual reality platform for 3D data exploration and collaboration. So basically what we do is we transform very complex data sets from the European Space Agency, from biotechnology companies, for example, into worlds that you can navigate and explore. So basically we transform data into understanding and let people use their imagination and experience to find insights from the data. So I'll try and blast through this. So this was the slide. VR platform for 3D data exploration. So the data we're talking about is extremely complex, highly dimensional, and it's the kind of data that we're generating more today than ever before in human history. But the way we have to explore it is broken. And so this is where we fit. We see ourselves as data translators. So what we'll show you today, I've done enough talking for now, is how we're going to transform a highly complex data set, so a big CSV file, what you would load in Excel, or normally what people do would be Python or MATLAB, into this. Then how we can navigate this environment, find insights from it. So the data you'll see is Nobel Prize winning data from Cambridge, our partner, and how eventually this will lead to creating new connections between far apart data sets. So cool, Alex, go ahead.
Awesome. Is it on screen?
I think so, yeah.
Awesome. Okay, yeah, so this is Lume. So what I'm going to do first is this is the menu. So it's point and click, nice and easy to use, and these are your controllers. So what I'm going to do first is just load in some data we got from the chemistry lab at Cambridge University, who we've been partnering and working with. So that was just 800,000 points loaded instantly. And if I just pull the world over here, we can see that every one of these points is instantly being rendered and turned into a three-dimensional object. So for better viewing, I've just lost tracking for a moment. Oh, no. Oh, there we go. Cool. So what are we looking at here? So over here, we have a full white blood cell, and over there, we have the top half of a white blood cell. So let's go towards this one over here. So the reason why the scientists love this at Cambridge University is because what they're doing is they're using a technique called super resolution microscopy to scan in these cells. So these are actually how they look in real life. They're not artist renditions. And they're capturing every single one of these points. And if you look, these purple points are proteins, and these red points are cell membranes. And they were trying to work out the distribution of proteins on the cell membranes. And they originally thought that all of these proteins were just appearing on the arms. However, as you can see from this data, you can see these points are all over the shell of the membrane as well. And this is really important for their research. Another interesting tool they really like about Lume is the ability to, I lost track again, the ability to capture data really rapidly. So what I can do here is, oh my God, I'm losing tracking. Cool. Literally just select data like this, and then just quickly export it, and that will save all this data back out to a CSV, which is exactly how this data was loaded in the first place.
So yeah, basically it's really interesting. Rather than doing this either in code or by just using 2D interfaces, we can do it very naturally. So when you have like highly complex data sets, this becomes quite useful.
Yeah. So another reason why the scientists absolutely love this is because we can carry out some data analysis for them, right, in real time. So something they use for their data is a process called nearest neighbor, which basically means what you want to do is you want to find some points. Oops, sorry. Whoop. Get rid of that. Find some points. You want to check the distance, and then you want to know how many neighbors this point would have in the whole data set, given that distance. So if we go over to here, our dashboard, I've lost tracking again.
Maybe move back a bit.
Awesome. So if what we can do is we can set our distance threshold to find out how many neighbors points have at a certain distance. So if we check this down to about 0.6, it will crunch nearest neighbor, and then what it will do, it will highlight all the distributions of neighbors that these points have at that distance. And here we have some information, so we can say the most common neighbor at this distance is 1, and then percentage of points with neighbors is 12% of this data set. And if we just click this, we can see a little minified version of all the clusters of neighbors, and we can say that, oh yeah, so 412 points have one neighbor, so we can say that. And then we can check this one over here, little cluster, and we can say, oh yeah, okay, at this distance, 50 points have 2 neighbors. Awesome. Let's get rid of that.
So this is interesting, because normally the way that we would do it is we would make a prediction, run the code, wait, see it. In this case, we try to bring a more natural feel to data exploration, so do it in a more seamless way.
Awesome. However, we don't only do just data that's been scanned in from a super microscope. We've also been working with the ESA, and this is a black hole simulation of neutrinos being shot into a black hole.
So this is data we've been working with the European Space Agency, and they've simulated how neutrinos behave when approaching black holes.
So what's interesting about this data is it doesn't just have 3 dimensions, that's 4. So it has an X dimension, a Y dimension, a Z dimension for your spatial, and then it also has a ray dimension. And what we can do is we can color this by that dimension. So we can say that the first rays are blue to the last rays, which are pink. And then we can take this a step further, and then we can animate this data like so. So what you're seeing here is every neutrino being animated fired in this direction towards a spinning black hole, which is in the middle.
So Alex, do you want to do the video stuff while I just explain? So we haven't adapted the software to work with this data. We just can animate any data set. So in this case, we're just stepping through the first points all the way to the last one. But if there is a time column in the data set, we can also read that. So what Alex is doing there is just creating a video. We only have 14 seconds left, so I'm just going to show you quickly how it's done. So very quickly, we can create videos of 3-dimensional data sets or multi-dimensional data sets that can then be exported into your social channels, which is very important, especially for research labs now, to have like a competitive edge, but also in keynote presentations. So really, we know that VR is still, kind of like a niche medium, and the ability to get this out is quite important. So Alex is just going to show you what the video looks like. So it's rendered at 60 FPS. We can go up to 4K in quality. So obviously you can do more work on like the quality of the data, the quality of the video, and everything to really create some cool stuff.
Awesome.
And do you want to show the data?
Yeah.
I know we're running over time, so sorry. So this only have like 4 columns, but you can load in up to, no limits. We do have a limit at the moment, sorry, of the number of points we can render, which is around 4 to 5 million. So yeah, thanks a lot.
Okay, thank you very much. So it does seem a little bit, confusing for sort of a novice in VR. Is that something that you're trying to tackle to make this easy to use?
The interface, you mean? Yeah. So there are different ways we can approach the whole UI side. Yeah. But we went for a traditional point and click because it's something that people are used to. In general, people are quite good at exploring the world.
Okay.
Because they relate to the data, it's something that they are familiar with. And for the last 20 years, for example, in the case of the Cambridge data, they've only ever seen it in 2D. So. Okay.
And what are the best types of industries for this technology? I mean, you've given science is one of them. Are there other industries that this is a great application for?
So we're focusing on 3 verticals at the moment, which are biotechnology, so drug discovery, preclinical trial data visualization, academia and science, and financial services.
Okay.
So our three.
Okay. We do have a couple of minutes for questions. So if you haven't sent one up and you want to, please use the Slido app to do that. But let's look at the ones we have now. How many are in your team? Let's start there.
You're seeing the team right here.
Just the two of you?
Just the
Okay.
two of us, yeah.
Are you planning to expand and hire? Or?
So yeah, we're currently raising funding to go from an alpha stage, which is available on Steam since Friday. So if you have a VR headset, please have a go.
Okay.
Yeah, to grow into beta.
Yeah.
Okay. And how many hours did it take to create this application from Peter?
So many hours. So many hours. Yeah, we're developing this from R&D for about 12-ish months ago, and then this formed into a company about just beyond 3 months ago. So we work, well, tirelessly on that for about 8 months solid. So day in, day out, 6, 7 days a week, just constantly programming. Yeah, yeah.
Okay. And of course, funding. How much funding have you received, if any? Do you have...
So we're a spin out from a bigger company. So they are funding our development cost at the moment, but we're looking for external funding to continue the project.
Okay. And where do you see this project going? Last question.
So yeah, I think for us what's really interesting in working in this field is that we've seen people from the European Space Agency see, the position of the stars, the closest stars to Earth. We've seen data from Cambridge, archaeologists. Like, the way we navigate data sets at the moment is so archaic and two-dimensional. It's really difficult when you go online. There's a lot of data available, but there's no one platform to kind of aggregate all of this information and create incredible connections between them. We're like fascinated by so when Alex was showing, the nearest neighbor, imagine you can get the data from MIT, Cambridge, and Oxford, all of these research groups with their separate data sets, and you can run the same analysis on all of them simultaneously. Creating an open data environment where you can explore is where we're going.
Okay. We have one more here from Seb. What's the benefit of using VR rather than using regular 2D screen applications?
So yeah, you can visualize, for example, three-dimensional point clouds in 2D. There's also a limit of how you can comprehend that data set. But for us, really, the kind of unique selling point is the fact that we can comprehend 4 millions of points and navigate them the same way we would navigate forest when the first man kind of walked into one. Like, we can see patterns in a natural way from very complicated data sets, which is harder when you're kind of like looking at it from above.
Okay. Well, thank you very much. This is very
thanks
interesting
a lot for
technology.
your time.
Good
Thank
luck.
you.
Okay, next up we have PhotoMine, which is going to talk about how to use technology to scan